guys, this is Felix from Automation Elix. Today I'll be doing a program example of calculating 5 analog signals instead of just 5 signals. And then it's like you are getting your hands on data manipulation instruction in a PLC, how you move around your data. And this is mainly especially for students. These are for students, college students. I'll be doing a PLC question, and then I do an answer. I do a question and then I do an answer on how you program the situation, how you solve the problems. So I've got different types of questions. I'll be doing one on each video. See, this one is another different, etc., etc., as we'll be moving on. So I'll be focusing, I'll be specializing on Delta PLC. So I'm gonna create and I assume at this stage you know how to play around with the Delta environment. I'm gonna do a video of how to use the software at a later stage. So don't worry if you are not yet used to this kind of software. Just go and see the video that I'm going to upload on how to work around the software, how to download it. It's for free. The software is for free from Delta website. The communication manager is for free from Delta website. I'm just going to do a video so that you see. So we're going to start now. Create a new program. Yes, I want to create a new program, and then this is average was its average calculation. And the PLC I'm gonna use, instead of selecting SA, and SA is a bit smaller PLC, so the instruction that I want to use are not supported by SA type. So I'm gonna select SA2, SA2 CPU, because there's a function that I want to use that and that is not supported by an SA. So what we're going to do is like I click OK. Yep. What you're going to do is like, here we are in this is our environment. I'm gonna create a new program. This is the program organizing unit, and then new program. We just leave this as it is. You can say main if you want. It's cyclic because you want to continuously scan, and then it's a ladder logic. That's the language that we are using. So this is our environment. So what I'm going to do, I'm just going to go deep into the question. So we need to move this data to somewhere. When you're adding network, you click this arrow so that we can play around with it. You keep pushing down so that we can able to manipulating it like reading from a certain memory location. So we must move this data somewhere. So I'm gonna do like different ways of how you can approach this situation, like different approaches. So I'm gonna move, copy, paste, paste, paste. So I'm doing this way so that you become used to how we can transfer data from one point to another, 1 2 3 4 5. Now we have 5. So where is this coming from? This is coming from calculation, our general calculation. When you are calculating average, you know, when you're calculating average, let's say it's 5 plus 5 plus 5 plus 5 plus 5 is 25. This is average. So to calculate the average of this, you say divide this by 5, then you should get 5. So right now the calculator is not going to do it for you, but the PLC is being asked. You are being asked to program, and the part of the program is requiring you to calculate the average. So what you do, I say load M1000. I say load M1000. What am I doing when I'm loading M1000? Instead, it means this instruction must run continuously. It must be scanned continuously. It doesn't need a condition for it to be activated. So you just put this one. Whenever the PLC goes from stop to run mode, this function, this conduct is closed. so this instruction is always enabled. Then you can do it this way. You can take your normally closed, then you paste it there, and then I say M1000. So there are different kind of ways that you can do this. 1, 2, 3, 4, and lastly 5. So I'm gonna be calculating 25 at first, so I'm gonna put 5 there, 5 there, 5 there, 5 there, 5 there. Right. So at first I'm going to calculate this. So where I want to transfer this data into a certain memory location, and then I will take this data from this memory, and then I start to calculate. It's data manipulation. I can do it in an easy way by just adding them straight, but I want to do this for learning purpose. So I'm gonna put it in D0. This is D1. I will do also tutorial on how to use a move instruction and why it is it necessary, and D2, D3. I like to use Windows 7. It's a good operating system for programming. Right. This is our data. The data registers are up to 4 because we're starting to read from D0. So what we're going to do now is like when I compile, it's saying I don't have an error now. So keep checking when you've done something. Just check if you missed something. The PLC will tell you at the bottom here that there's an error or not. So if I'm to simulate this, you're gonna see the data is gonna move from this point to that other point. So what I'm going to do, I open my communication manager, my driver simulator is driver 3, and then SA2, the PLC that I'm using is here, so it's fine. And then I click start. I'm going to do tutorials also on how to use this simulator and everything, right? You go on communication. Remember our simulator is on driver 3, and then OK. And then I go online. I'm downloading. So the PLC is assuming I have connected the PLC, and right now it's saying in stop. So if you try by any means to simulate anything, you can see it's in stop mode. So you must put your PLC in run, because if it's in stop, it's like a PLC that is on but it's on handbrake, so it won't go anywhere. So right now we are in run, but we are seeing 0000. It's like in decimal, but we are not working with the decimal. It must be in floating, it must be in integers, because this one is an integer. So you go to view, and then you change your data to unsigned. So it means the moment we switch on this PLC, this M1000 just closed there and there, and then the data which was on this side, the left side of the move, was transferred to D0. So we now have 5 in D1, 5 in D2, etc., etc. So we are now moving on the additioning function when you are adding our data. So what we will do is, like, I go offline, I put add, right? I come here, I put add, right? So what am I adding? First I'm adding D0 and D1. Then I put the answer on the side, and then I add this one and this one, and then I put the answer on the side. I'm just doing the adding function. So don't forget your M1000, because it must be a contact this side. It's very easy, right? So firstly, this network, I'm gonna add the data which is this side and this side. So I'll move D0 and D1, right? So next I'm gonna add D2 and D3. D2 and D3, like that. So what's happening now is, like, you now have data. The only data that we didn't add is this one here, because our add instruction only supports 2 registers back here. So I'm going to show you a shortcut of doing it, but I'm starting with the long way so that you have the basics. After this, we're going to do it another way, a simpler way, right? With a Wsum instruction where you just sum everything at once. It's the easiest, but this is important for you to understand data manipulation, how you move data across instruction when you want to perform like calculations or stuff. So you add here. So what we have, take note, we add D0 and D1, and then we add the data of D2 and D3, but we didn't use this. Take note, we have not added this, so it's still left out. So what I'm going to do is like I'm going to move this to, let's say, you can pick any register. You can pick any register. Our last register was D4, so I'll move this data to D5 and this one to D6, right? So what I have now is like I've added this function, network 1, and this function, and this function, and this function. So the answer for D0 and D1 is being stored here. The answer for D2 and D3 is being stored here. Then I go on again, and then I say add. So I now need the answer in D5 and D6. And then here I've got D5 and D6. I'm going to put this value in D7. Right? Just see how the data is flowing. We are moving data from point to point, point to point, point to point, point to point. So what's happening now is I've added network 1 and network 2, and then I've added network 3 and network 4. And then the answer for these two is this side. The answer for these two is in D6. So now I'm adding D5 and D6, and then I'll put the answer in D7. So it means right now in D7 I have the answer of adding this one and this one and this one and this one, but not this one. So when I'm here now, I'm going to add now now I'm going to add D7 and what? D7 and that and this other number. Both is we are just adding in this other number. So which is D4, the one we just left out, which is D4, and then I'm going to put this answer, let's say, in D8. So what I'm going to do, I'm going to compile, and then I download, and then I see where we are standing now. Alright, so now you can see that we have 25 in D8. Take note what's happening. We've already explained this function. Our data is has been moved to D5. Now what we have is saying 5 plus 5. We have 10. We added the first network D1 and D2, D0 and D1, and then we are coming to the other network. Is saying 5 plus 5. We now have 10 here. Remember, we left out this one. We left out this one. This one is just still standing behind. So I now have these two answers, and then I add those two answers here. I now have 20, but I still haven't add the other one. Why is it like this? Because this function can only add 2 registers. If it could add 3, I could have just put all of them at once. So that's where we are standing now. We now have our 25 here, and then we are now going to calculate the average. So we need to divide this by 5. So I'm just going to say div, and then I put my load 1000, and then I say my answer is D8. I'm going to put the answer in D9 here, and then let me just see how it goes here. Right, D8 divided by 5, that's what you get. That's what you get. Right, you see now, D25 divided by 5 is equals to 5. We now have our answer. So that's how you calculate average. So now I'm now going to do it in a more simpler way, than this one. So let's do it in a different method that is a less confusing, and it saves more time and it saves more PLC memory. So this was just for you to understand how data is moved in PLCs and stuff. If you have any question, just comment below and then I will just answer you there and there. So let me do it the other way now. So what we are going to do, I will delete this for the sake of avoiding confusion. So just copy it, and then maybe if you want, you save it now as another program, and then you create another program with this new function that I'm doing now, right? But I'm going to use other registers though. I'm not going to repeat to avoid confusion. So our last registers was D9, right? Oh, yeah. Okay guys, so now we are doing the other way around. So I'll keep this network from D5, from D0, D1, D2, D3, D4, D5. This one remain the way it is. So now we are moving on to the other new function now. So I'll say load M1000, right? And then I say here Wsum. So this process will avoid the idea of doing, you add this and then you add that, you add this and then you add that, you add this and then you add that. It reduces, it's less time consuming. So what you're going to do, you double click, you move into the instruction. It's saying source device, data length to be summed, and then the device for storing the result. So what this will do is like it will add everything from D0 to D4 just there and there. So what you do is like you add your first register here, let's say D0, the data of the registers that we are adding. How many registers are we adding? We are adding D0, D1, D2, D3. So we say 1, 2, 3, 4, 5. So I'm adding 5 registers, the data that is in 5 registers, and then I'm going to store this value, let's say in D10. This is Wsum. So what I will do next is I'll say download, transfer, and I say OK. Then I come online. You can see now I'm sourcing from the first register, which is D0, and then I specify, but this has to be in a chronological sequence, incrementing. You can say D0 and then you put D10 here. You put a register, or let's say D20, and then you say add 5 registers. It's not going to add. It adds by incrementing, like D0, D1, D2, D3. If you are starting from D10, it will say D10, D11, D12, until it gets to the number of data that you are adding. You see, so take note of that this register, it increments from the first register. It counts 0, 1, 2, 3, 4, 5. You can put D0 and then you want to add another data which is in D20, and then you use this function. So you see now it reduces the programming time and it reduces the confusion. So take note of it. So now we are going to divide. Division is the same. So now I'm going offline. I'm just gonna do this, and then I say double click, I say div, I copy. I'm getting a little bit lazy here. So I'll be doing this PLC question and answer. It helps you when you're practicing. I don't just teach instruction, but I solve the problems, the questions. I would we put on a question, a problem, and then we solve it. So D10 divided by 5. Then we store our answer in D11, something like that. And then I download. There you go. Right, you go online. You see now, our answer is 5. If we check how many network we use, how many data, how many functions that we use, they are just the same. I mean, they are a bit less from the previous way of doing it, but the previous way of doing it is important because there's sometimes where you need to move data around until you get it to where you want to use it. So that way is important, especially for you guys when you are learning. It's very important for you. I always want to do it the hard way when you're learning, and then when you're now doing this, it's like it's easy, but you have the basics. It's flexible for you. If you come across a PLC that doesn't support this Wsum instruction, it means you have to do it the other way around that we did earlier. So it's important also. So the other way is like you just put your instructions straight into the addition and subtraction function. So let me do that one for you, and then I think that's right. So what we are, I think we are done here. I'm going just to do that straight programming, straight addings, no moving around in registers and stuff. So we're just gonna say we put our add here, copy, paste. So this is another method of not moving, like you don't have always to move your data from 5 to D0, 5 to D1. You can just edit and work with it straight as it is. So you can just punch it into addition straight, but the best way is moving your data so that when you want it, you can access it easily, and you can even change it remotely, maybe from a remote location, like from a SCADA system. I don't always advise to write data permanently unless it needs to be there. So here you say 5 plus 5 plus 5 plus 5. You see. So what you do is, like you say, let's say D12. That's the first two, those are the first numbers, and then here say D13, and then here you say D13 plus 5, and then you put your answer in D14. Right. So what it means, you add these two, then you add these two, and then you store the answer in these two registers. I made a mistake here. It's supposed to be D12. Right. I add these two, and then I add these two, and then after adding these two, I add them also. So it means now I'm on 20. I have to add another 5. So let's say also paste, and then add D14 plus 5. Then you save in D15. So now we are on 20 now, because we've added 5 plus 5, 10. 5 plus 5, 10. It's now 10 plus 10, 20. That is what we have here. And then after this, you divide. I think you now know the drill. Right. Divide. So I divide D15 by 5. So the answer in D16, something like that. I think this is the last. So there you go. We add. So I'm just showing you that it's not always where you have to get this data from a memory location. You can just punch it straight here. you can just punch your figures here straight. So it's easy. That's how you calculate an average of 5 numbers, or they could be 6 or whatever. And then if you want, use the Wsum. So it's like you might know these instructions by just learning them, but you need to know how to use them. So this is how I help you to familiarize the instruction by solving problems. These problems are from existing situations. Sometimes they are the problems that I've met. So that's it. So our next question that we'll be doing in the next video is for these two, the two pumping facility. What? We'll do that, and then we come to this one, we come to another one. So write a PLC program finish. So I'll keep doing and keep doing and keep doing. There are a lot, and they become complex. So thank you guys. Don't forget to subscribe. Thank you.